Hey guys, welcome back to the next video. In this video, we are going to understand about the workload management. The next topic on the workload management, we're going to understand about the resource request and limit. We're going to see both these concepts as part of one's, hands-on video. These both concepts are part of a single YAML file, as you can see over here. So we're going to execute two different YAML files, one which we expect it to succeed, one which we expect it to fail. So I want to show you that before we go ahead, and I want to show you with a smaller level of example so that you can understand it much better, rather than having talking about 2 cores or like 4 cores processor and plenty of RAM. Let's stick with the very basic stuff of 1 core processor and 1 GB of RAM so that you will have proper understanding before proceeding further. Now, before talking about the left side of this diagram, which is the actual YAML file, let's talk about the right side of this diagram. On the right side of this diagram, you have something called resource allocation for Kubernetes, which is primarily responsible for, which is the primary responsibility for your Kubernetes scheduler. But before it goes to the scheduler, as we discussed earlier on the previous workload management architecture diagram, the YAML file will be executed through kube control, and then the API will be called, and then the kind, which is actually the name of your API, will be called upon. And within that, all these configurations will be loaded into your etcd, and then the API scheduler will be called upon to schedule the workload on the whatever the worker which it is choosing. Now, in this example, let's just take, for example, that we have only one worker, one node. Okay, so that's easy for us to understand. So Kubernetes scheduler, what kind of what is the responsibility? We will look at the Kubernetes scheduler first before we proceed further. The Kubernetes scheduler is responsible for placing pod onto the nodes in the cluster. When a pod is created or needs to be rescheduled, the scheduler evaluates various factors such as resource requirements, node capacity, and other constraints to determine the optimal node for the pod. It ensures that the pods are distributed across the cluster in a balanced manner, that each node has sufficient resources to accommodate the pod scheduled onto it. So this is the whole purpose of a Kubernetes scheduler. Now, in terms of kubelet, which is running on that particular node, worker node, the kubelet is an agent that runs on each node on the cluster, and it is responsible for managing the pods running on that node. It communicates with the Kubernetes API server to receive pod specifications and ensure that the pods are running as expected. The kubelet enforces resource constraints specified by the pod's configuration, such as CPU and memory limits and requests. It monitors the resource utilization by these pods and take actions to enforce that the resource limit, and it prevents resource overriding each other. If a pod exceeds its resource limit, the kubelet may throttle the pod or terminate it to ensure the stability and the performance of the node. So that is where the kubelet stands out in terms of working on par with your API scheduler and keeping the API server in loop about those resources which has been consumed either by request or limit, and making sure that this process goes through in a orderly manner. So that's the whole idea of having the scheduler and kubelet working together. Now, why we are discussing about this? Like, we're going to talk about resource request and resource limit. Now, I put this word request, I put this word limit to understand where each of them stand. So if you take a typical configuration like this YAML file configuration, now, this is a replica configuration. You can see that it has 3 replicas over here. Until this particular line, we have all seen this so far. There's not much changes. You pretty much understand everything over here. What happens after this is what the question is all about. So this little piece of information controls both request and limit. Now let's understand one by one. Before we go to the explanation, which I will come to that later point of time, but let's just hold on from there. First, let's understand how this architecture comes into place. Now, first, let's understand the resource stack. So within the resource stack, you have the limit and then the request. It's on the same level. And within the limit, you have CPU, memory, and within the request, you have the CPU and memory. So there's no changes here. So there are only two parameters here, which both limit and resource uses. And that is your CPU and memory. So these are the two parameters. That is one thing for sure. The second thing I want to discuss with you is that what is limit and what is request, right? So both are coming under the resource topic. Both are under the workload management. So it is something to do about the workload, about how you can customize the workload and where the pods will spin up. So that's basically it. And one more thing you need to notice that it is not in the pod level, but it is in the container level. So which means whatever we are assigning here is for this container. So if you're going to have multiple containers under the pod, so you may have to define this for each containers which you're going to have. So that I want to clear it off first time itself. So if you have multiple containers inside a pod, then each pod is going to have a resource limit and request. Okay, so that's one thing I want to take it off the way. So there you go. So now this my container pod with my image, okay, so that is going to come with these two items. Now what is limit and what is request? Now request is basically, it's requesting that the host should have minimum of this particular CPU and memory available or free, okay, and it's very much available. So this is the request. It says that it is requesting that then worker one node should have this much of free CPU and this much of available memory on it. That's the first criteria. The second criteria is that it is going to restrict this container, which is running in the pod, to have only a maximum of 1 CPU and 512 MB of a memory. So what this means is that your kubelet is going to monitor your pod, making sure that it doesn't exist 1 CPU and 512 MB of RAM. What happens if it exists? If it exists, it will either throttle, which we will see later, or it will basically terminate the instance and create a new pod. So that's basically what is expected or what is the outcome of this particular activity. So the question is like, as we have 1 core free CPU and 1 GB of RAM, and I'm assigning a limit of my pod to have 1 core CPU and a 512 MB of RAM. Now, will this be assigned immediately? Like, for example, the RAM be consumed immediately and the CPU would be consumed immediately? No, it doesn't. So this criteria of a limit only says that it cannot exceed that. So that doesn't say that the pod can, if the pod is not utilizing that 1 CPU of a CPU or 512 MB of a RAM, it will not be even assigned to that pod. So it will be idle state. So which means that your operating system or your worker node can use that process for anything else. But the moment there is a requirement and the processing starts, then it will be allocating that 1 CPU and 512 MB of a RAM as a maximum. So that's what you should understand before we go further. Now, the next thing we are going to understand is about this. So if I have such a system wherein which that I have 1 core preprocessor, 1 GB of RAM, and in this situation, would it work? So here, if you just understand this, the pod requests 0.5 CPU cores and 0.5 CPU cores and 256 MB of memory. And the pod limit says that 1 CPU and 512 MB of limit. Okay, if the if the node has one core CPU and 1 GB of RAM, the pod will be scheduled. There will be no issues, okay? Because your request of your CPU is 0.5 and what is available is one CPU. And what is the request of your memory is 256 MB and what you have is 1 GB of RAM. So there should be no problem in getting this pod assigned on this particular worker node. Now, what if your resource limit is 1 CPU and 512 MB? So here is the pod request is 2 CPU. So here if you say that the request is 2 CPU and you need to have 2 GB of memory as a request, okay? And the pod limit is as the same as we discussed earlier. However, if the node has 1 CPU and 1 GB of RAM available, the pod cannot be scheduled because its resource request exceeds the available capacity of the node. So which means that what it is doing is like it's comparing the request, CPU request, 2 CPUs, but it has only 1. And memory, it is looking for 2 GB, but it has only 1 GB of allocation on your worker node. So therefore, the pod cannot be scheduled on this node. So we will see both these examples. One, where in which you have sufficient request, and two, if it doesn't have a sufficient request, what it is going to do. So both these scenarios we will explore on the hands-on session. And request and limit is one of the important interview questions which people ask, because the first thing they'll ask is, what's the difference between resource limit and resource request? And you should be clear enough to understand the concept to explain to the interviewer that request is nothing but what it is looking for on the node system to schedule the pod, and limit is basically constraining the pod within that whatever the limit you're setting for your CPU and memory. This simple explanation will get you to the next level or the next question successfully. Thank you again for watching this video. If you have any questions, leave it on the question section. I'll see you on the next video.